this qualitative analysis, we are going to work on a mixture of two salts, just like the question said. C is a mixture of two salts. Carry out the following exercises on C. Read your observations and identify any gas or gases involved. State the conclusion you draw from the results of each test. Add 10 cm³ of distilled water to C. Stir thoroughly and then filter. Keep residue and filtrate. Test the filtrate with the litmus paper. Then to 2 cm³ of the filtrate, add 2 cm³ of iron sulfate, followed by slow addition of 1 cm³ moderately concentrated tetraoxosulfate 6 acid. Then CI, transfer residue into a boiling tube and add 5 cm³ of dilute hydrochloric acid. Then to the second question, say boil the mixture from 2CI and allow it to cool. Put the residue into a boiling tube and heat strongly. So we're going to follow this instruction strictly. One of the major reagent we use in this test is hydrochloric acid. We're going to be using hydrochloric acid and sodium hydroxide. If you don't know how to prepare reagent for hydrochloric acid, you can just dilute about 6 cm³. You measure out 6 cm³ of concentrated hydrochloric acid and dilute it into 500 cm³ of water. It will give you about 2 mole per dm³ of hydrochloric acid, and that can serve as a reagent. For sodium hydroxide, you can actually measure out 40 grams and dilute it into 500 cm³ to get about 2 mole of sodium hydroxide. By so doing, you have the reagent, and then we can start. Let us start the analysis and record our results. So, in this recording of our results, before we perform any test, we have to record the test first. Then, after the test, we record the observation and the inference. One thing you must note here is that the inference carries more mark than any other aspect. The test does not have any mark. The mark in observation and your inference is the one that carries mark. Wrong observation can make you to fail the inference, even though when the inference is correct. And if you observe well and the inference is wrong, you will still lose mark. So anything you are doing, you have to make it short and correct, specific, short and simple, no complex things here. The first question said, C is a mixture of two salts. It said, replicate. It said, add 10 cm³ of distilled water, stir thoroughly, and then filter. So water plus C, water plus C, water plus C, filter. Water plus C, filter. We have to stir thoroughly for the decomposition reaction to properly take place. Say thoroughly stir. This is C mixed with water and thoroughly stir. The first thing you do is you fold the filter paper. 1, then fold it into a cone. 2, then open the filter paper by the side. Open one side of the filter paper. Because I used 2, I have double layer this side. Open it this way. Then my funnel, I pick my funnel, just add some quantity of water, touch some quantity of water on the funnel so that the filter paper can stay well inside the funnel, and then insert this inside the funnel. It will also help the filtrate to move faster. Then shake very well, shake vigorously, shake very well to get a homogeneous mixture, and then pour gently to avoid overflow. Pour. It's filtering gently. Filtration is taking place. It will take quite some time. So because our filtrate is not totally clear, we have to get a clear filtrate. I'm going to refilter this again. I believe that the residue or the precipitate you are seeing on top is as a result of the weakness of the filter paper. So because of continuous filtering, it becomes light and the precipitate starts. So I'm going to refilter this again to get a clearer precipitate. So by so doing, I'm going to pour it inside this filter again to refilter so that I can get a clear filtrate. Alright, you can see clear filtrate now coming out. You can see clear filtrate coming out faster. Now because I've gotten enough, I can transfer this into this test tube. The one I have is enough for the next practical. I can keep this to avoid wasting my time, and then use this to carry out my experiment. So I can keep this for my experiment. So let's go to the next stage of the experiment. The next stage of the experiment said, test the filtrate with litmus paper. Test the filtrate with litmus paper. This is blue litmus paper. This is red. We're going to use red litmus paper. We're going to test with 2 litmus paper. You cannot test with just 1 litmus paper. So we test the filtrate. Okay, this is fully filtered. This is the filtrate, clear filtrate. So when we test with red litmus paper, test the filtrate with red litmus paper. Okay, it's turned red litmus paper blue. It's turned red litmus paper blue. So let's test with blue litmus paper. Let's test with blue. No effect on blue litmus paper. No effect on blue litmus paper. So we can record our observation this way. The first test is filtrate, very short, filtrate, filtrate, litmus paper plus litmus paper. Our observation has no effect, on blue litmus paper, but turns red litmus paper blue. When this is done, it shows that the filtrate is an alkaline solution. Add 2 centimeter cube of iron. That's the first instruction, followed by slow addition of this. So we're going to look at filtrate plus 2 centimeter cube of iron sulfate. Filtrate plus 2 centimeter cube of iron sulfate. So we're going to add 2 centimeter cube, which is equal amount of this, into the filtrate. This is freshly prepared iron sulfate. So filtrate plus this, we have green precipitate. So filtrate plus iron 2. In our observation, we have green precipitate. 2. An addition of concentrated tetraoxosulfuric acid.
React.
An addition of concentrated tetraoxosulfate 6, you can see the brown ring at the bottom of the solution. You can see the brown ring formed there. This brown ring shows the presence of NO3 minus ion, nitrate 5 ion. Alright, let us write our report now. So the conclusion, now green precipitate form, then filtrate plus 4 plus conc H2SO4 the green PPT disappeared. The green PPT disappeared, and a brown
Green test.
ring formed. A brown ring formed NO3 minus confound solution. NO3. Transfer the residue into a boiling tube and add 5 centimeter cube of dilute HCl. So residue plus HC, so residue plus dilute HCl equals residue plus dilute HCl equals, let's look at what our observation is going to be. Instruction said residue plus dilute hydrochloric acid. You put in your, you put the dilutes. You can see effervescent taking place. If you wet this, if you wet too and check the gas, if you test the gas, to test this gas that is coming out, effervescent occur, a gas came out, you can see that the gas that is coming out gradually turns blue litmus paper faint red, turns blue litmus paper faint red. This gas again, by using our bong, if we put our bong and add lime water to a test tube to see, okay, so the gas is not coming, little quantity to flush it down, effervescent occur. You can see the lime water is changing milky. You can see that the lime water is changing milky. You can see that the lime water is changing milky at the entrance of this gas. The lime water is changing milky. You can add small quantity again, add little quantity of hydrochloric acid again to wash it down. Alright. You can see, as the effervescent occur, the lime water turns milky. As the effervescent occur, the lime water is turning milky. As the effervescent occur, the lime water turns milky. So this gas is a colorless, odorless gas that turns blue litmus paper faint red and then turns lime water milky. Effervescent occurred, effervescent occurred, a colorless, odorless gas evolved, which turns blue wet, blue litmus paper, wet blue litmus paper faint red, and turns lime water milky.
To my right.
Residue plus a colorless, odorless gas evolved, which faint red, and turns lime water milky. CO2 evolved and CO3 2 minus confirmed and allowed to cool.
Specimen E.
The residue plus dilute hydrochloric acid plus heat, the white PPT disappears, forming pale yellow solution. This white PPT reappears on cooling. Lead 2 ion confirmed. Alright, the fourth test said put the residue into a boiling tube and heat strongly. So residue plus strong heat.
Baby, good look.
I see no
Can you see the color change?
They were couples.
There's pirates.
Why you guys get go
So why are you turning red?
Reddish yellow color.
Turning red.
Brick red. I got brick red.
Is that?
What's
Brick red.
turning
Okay.
red?
Brick red.
Actually, no.
How is it red?
I think it was nice.
I like the one when they fight.
Now this color shows the presence of
Precipitates.
chloride, lead 2 chloride. So the change in color from white to brick red or reddish yellow is a confirmation of lead chloride. So in our report, we're going to write
Okay.
Focus on something.
So these are just the gray.
Yellow deposit.
Yes, you
reddish yellow deposit.
Shut up, we gave you boss, it's yours. It's possible.